Hello everyone, my name is Ammar Mustafa. Today I'm going to talk about my final year project, which is titled Fix Finder, a specialized vehicle repair system. Uh, I'm from School of Computing. My supervisor is Dr. Radzia Binti Muhammad. So the content of the project, which is the introduction, we have the literature review, the system development methodology, the requirement analysis and design, and at the end, the conclusion. So for the introduction, car owners sometimes face various obstacles, causing them to get irritated, to get their repairs delayed, and to increase the estimated cost for uh, for repairs. Many owners lack the technical experience to choose appropriate parts. Also, some repair shops overcharge some customers. Um, some customers find it difficult to identify necessary parts and the best repair parts. So, some customers also think that this issue is time consuming. So, they just push it off with anything. So, my project aims to design a user-friendly interface for the Fix Finder vehicle repair system to replace the traditional word-of-mouth approach. Um, for the project objectives is to streamline the process of identifying repair parts and locating suitable repair shops for vehicles. So also for the creation for creating an architecture model for the fixed finder vehicle repair system based on the gathered requirements, ensuring it can efficiently handle search for repairs. Also, one of the project aims is to ensure the system can correctly detect vehicle models and provide accurate repair parts suggestions and display reliable shops locations. As for the project scope, so the project is to replace, as I have said, the manual identification, word of mouth recommendations, phone directories, in-person visits, and the mechanic recommendations with a digital system. So it also automate vital system processes to increase efficiency and reduce time consumption for users in Al Kharj, Saudi Arabia. Also, the system will be limited to specific car brands and models, including only Toyota, Hyundai, and Kia. For the literature review, we have the current system analysis. So for the current system analysis, we have an algorithm that can analyze the image to identify and locate the vehicle, classifying it by make and model, which is the image recognition technology, which will be using the artificial neural network. We have the system identifies the necessary repair parts for the vehicle. So the system will search the database after identifying the vehicle make and model and will show the user the repair parts that are perfect and precise for his vehicle, accurate for his vehicle. There will be an estimation of the cost of these parts for the user, as well as the system searches for suitable high quality repair shops in the user's area, based on the of course the high rating and positive comments from other users on Google Maps. So for the technologies used or going to be used, for the front end, we are going to use React. For the back end, which is the Node.js. For the database, it's going to be Firebase and Firestore. For the version control, we're going for GitHub and the diagram tools that created most of the diagrams of this project, which is Draw.io. So the development methodology. So I'm going to adapt the agile methodology, which consists of uh, 5 to 6 phases, which is the planning phase, the requirement analysis phase, the designing phase, implementation phase, which is the development phase, the testing phase, and the deployment phase. For the hardware requirements, we're going to need a laptop. So since my laptop is an MSI Stealth M15, it has a CPU of Core i7 11600, and the RAM is 16 gigabits. As for the software requirements, I'm going to use the operating system of Windows 11, the Visual Studio Code. Lucidchart is similar, it's the same as Draw.io, it's typically the same. And Figma for the project prototyping. This is the use case diagram of my project. It has a total of 9 use cases, which are the registration of user, the login, the image recognition technology, the database search, the view parts, check prices, find repair shops, give ratings and comments, and view ratings and comments. This is the model view controller. It's the architectural pattern of my project. Uh, as you can see here, the views, the home page, image recognition, the view parts page, and so on. Here, as you can see, the user interfaces. I have put 2 examples of the user interfaces, which is going to be created, which is the login page and the home page. In the login page, the user can enter his email and password and log in. If he doesn't have an email or a password, he can click to register. In the home page, it talks about the system, the Fix Finder, what it aims to aid people in, some of the services that it provides. As for the conclusion of this project, the achievements of the project is to engineer requirements for streamlining the process of identifying the repair parts and knowing the location of suitable repair shops, which we have finished the engineering of requirements in FYB1. As for the second point is to design and develop the proposed system, which is the Fix Finder repair system, even though the development is later in FYB2. And the last point is to test the proposed system for system performance and user acceptance. This part is going to be done after I finish my FYB2. So future plans for FYB2, which is going to be the development for the Fix Finder system based on the requirements I have identified, and also to test the development system for system performance and user acceptance. Thank you for listening to me and have a nice day.